Hi there, and thanks for tuning in. This is going to be your Algebra 1 Semester 1 review. So let's go ahead and get started with going over your packet. The first thing we're going to do is go ahead and solve number 1. So we're going to subtract 13 from both sides, and we're going to get negative 15 is equal to x since we have the same signs there. For number 2, we did have to distribute first, so we're going to show that right here. Negative 5 times negative 3 is a positive 15, and negative 5 times negative k is negative 5k, and that's still equal to 60. The next thing we're going to do is subtract 15 from both sides. So we get 45 is equal to negative 5k, and when we divide both sides by negative 5, we get k is equal to negative 9, number 2. For number 3, we're going to still distribute first. So we're going to distribute that 8, so we'll get 8 plus 8x plus 24 is equal to 88. We're going to go ahead and combine any like terms we have. That's the 8 and the 24. That's going to make 32. So we'll have 8x plus 32 is equal to 88. And now we're ready to start solving for x. So I'm going to subtract 32 from both sides. So I get 8x is equal to 56. And dividing both sides by 8, that means x is equal to 7. For number 4, again we see some distribution, and we do have variables on the same sides here, or both sides, so we'll have to do a little bit of extra work here. Once I distribute, I'll get negative 5r plus 32 minus 4r is equal to 28 minus 7r. I'm going to go ahead and combine my like terms over here. Negative 5r and negative 4r make negative 9r plus 32 is equal to 28 minus 7r. What I'm going to do is make all of the r's go to the right side because that would make my r's positive. And then that means I'm going to move my 28 to the left side. So all my constants are to the left. Okay, so 32 minus 28. That's going to give me 4, and it's negative 7r plus 9r, that gives me 2r. Dividing both sides by 2, r is equal to 2. For number 5, again distributing first, so I get negative 7v minus 28 is equal to negative 37 minus 4v. Again, I have variables on both sides, and again I'm going to move my variables to the right side to make them positive. I'm going to add 7v to both sides. Even if you moved your variables to a different side than mine, you should still get the same thing once you're done. So negative 28 and a positive 37, you're basically just subtracting 37 and 28. That's going to give us a positive 9. And then negative 4v plus 7v, that's going to give us a positive 3. Dividing both sides by 3, I get v is equal to 3. For number 6 here, let's see if I can scoot this over. Looks like no, so we're just going to distribute first. I'll have 8x plus 66 is equal to 8x minus 56. I'm going to go ahead and subtract 8x to the left side and subtract 66 to the right. And I'm going to get 0x is equal to this negative 112. So that's basically 0 is equal to negative 112. Equals 6 is 12 here to 1. That's actually 122, sorry. That is not true. So for number 6, we need to say no solution. Okay. Next up we have number 7. It says solve A is equal to L times W for L. So basically I just want to get L by itself. And what I'm going to do is just divide both sides by W. So I get A over W is equal to L. Same thing for here. Let's get R by itself. I'm just going to divide the whole entire side by 2 pi since it's all being multiplied. So I get C over 2 pi is equal to R. Okay, that was number 8. Number 9, remember for these you have to write 2 types of equations. The first one can just be normal, 3x is equal to a positive 6, but then your second one should be equal to the opposite, 3x is equal to negative 6. So really you can have two examples here, or 2 solutions. X is equal to 2 and x is equal to negative 2. So just remember, with absolute value, you're writing two equations. One is equal to the negative. So over here, we would still do that same thing. b minus 7 is equal to 14. b minus 7 is equal to negative 14. To solve, I'm just going to add 7 to both sides. So I get b is equal to 21, and b is equal to negative 7 for both my equations solutions for number 10. 11, same type of deal here. We're going to have 6x minus 6 equals 54, and then 6x minus 6 is equal to negative 54. My first step will be the same. I'm going to go ahead and add 6 to both sides. Each individual one, just give a different outcome. For the first one, I get 6x is equal to 60. That means x is equal to 10 for the first one. For here, I'll get 6x is equal to negative 54 plus 6, that's negative 48, which means if I divide both sides by 6, I get x is equal to negative 8. So 10 and negative 8 are my two solutions for 11. 12, I still need to write two examples or two equations here, so I'll have 5 minus 2x is equal to 25, and 5 minus 2x is equal to negative 25. I'm going to go ahead and subtract 5 from both sides. Again, we won't touch that 2x until we're done getting it all by itself. So I'll have negative 2x is equal to 20, and negative 2x is equal to negative 30. So for one, I'll have x is equal to negative 10, and the other, x is equal to a positive 15. Okay, so just a reminder, for absolute value, write your two equations equal to the opposite. For number 13, it says to solve the inequality and to graph it. So what we're going to do first is go ahead and solve this inequality. I'm just going to rewrite it below. And then I'm going to go ahead and combine my terms. I know negative 8x minus x, that's going to give me negative 9x. So 9 is less than or equal to negative 9x. You do have to be careful here, because when we divide by a negative, this inequality switches around to be the opposite. So instead of less than or equal to, it's now greater than or equal to. So I have negative 1 is greater than or equal to x, or you can even write it a little bit easier to help you graph it. X is less than or equal to negative 1. So that means I come over here to negative 1. That is a closed circle, and I'm going to point to the left. Either one of these solutions would work, but just make sure that you graphed correctly. For this next one, in number 14, I'm going to rewrite it below. Now I'm ready to solve for x. What I did is I moved all my x's to the left side. So minus 8 minus 8x, and minus 13 minus 13. So I'm going to get negative 4x is greater than or equal to negative 12. And I'm going to divide both sides by negative 4. Again, switching that symbol. So I'll have x is less than or equal to a positive 3. So that means I'm going to go over here to that positive 3. Again, that's a closed circle pointing left. So there are my two answers for number 14. Number 15, solve each compound inequality and graph its solution. So again, I'm going to write those below. Now that I have them written below, let's go ahead and solve for k. So I'm going to subtract 4 first from both sides. So k is less than negative 8. Or, and then over here, divide both sides by 8. K is greater than negative 6. So that's exactly what I'm going to do. I'm going to go first to negative 8 and show less than 8, open circle pointing left. And then go to negative 6, greater than negative 6, open circle pointing right. So again, now I technically have three solutions, my ors, and then that. For number 10, it does look like it's an and compound inequality, so let's go and rewrite that one. Now I'm ready to get n by itself. You could either rewrite these as two separate inequalities or just solve it like it is. The main point is to try to get n all by itself. So what I'm going to do is when I get n by itself, I need to subtract 7 from everything, because that's going to knock out this 7. So I'll have 3, 10 minus 7 is less than or equal to n, which is less than or equal to 12 minus 7, which is 5. Okay? So that means I'm going to come up here to the 3. That's a closed dot above the 3, as well as a closed dot above the 5. And n reaches to be between those two numbers. So I should just have those two dots connected. I shouldn't have any outside dots there since it's an and it's overlapping. Number 17, again, that's an or inequality, so let's go ahead and rewrite that. Now I'm ready to solve, so I'm going to go ahead and add 2 to both sides. Sorry about that. So your x is greater than or equal to 8, or x is less than 2. Greater than or equal to 8 would be a closed circle pointing right, and then less than 2 would be an open circle pointing left. So here again are my solutions. For number 18, I'm going to rewrite that one as well. This one does in fact say that it's an and inequality, so let's see how this one looks. The first one, I'm going to add 9 to both sides, so that v is greater than or equal to negative 9, and then over here I'll just divide both sides by 10. V is less than 7. So I could write it two ways. I could write it like this, or I could say negative 9 is less than or equal to v, which is less than 7. Both of these ways work because you're still showing the overlap that is happening. So what I would need to do is just go up to negative 9, and since my number line is being hidden right now, I'm going to write it down below. So here's what I have. I have negative 9. The first thing I'm going to do is go ahead and do my closed circle over the negative 9. And then for 7, that's an open circle, and they basically just need to connect. Okay? For number 19, with these, remember you have to write two separate inequalities. The first one will just be normal, so I'll have 9x is greater than 81. And then the second one, I'm going to do 9x and then flip my symbol and make it the opposite. So opposite symbol and opposite number that's separate from the variable. Let's go ahead and solve here. So to solve, I would be dividing both sides by 9. And this is going to be an or, sorry. So I'll have x is greater than 9, or x is less than negative 9. So I'm going to go over here to negative 9, it's probably right here. Less than negative 9 would be open circle pointing left, and then positive 9, open circle pointing right. It is an or because they do not overlap. Okay? For the next one in number 20, I'm going to rewrite this one down below. We can have x plus 8 is less than 16, or x plus 8 is greater than negative 16. When I start to solve this one, I get x is less than 8, and then here I get x is greater than negative 24. The thing with this one is if you graph it, you are going to notice that they overlap, so you do actually need to rewrite this one as an and. So negative 24 is less than x, which is less than positive 8. Because when you graph it, you'll notice they overlap. Look at here. Here's my negative 24, and then the positive 8 is all the way up here. And it has to be less than positive 8, but still greater than negative 24, so that means they're going to overlap in that section. Okay? Almost done with our first half. For number 21, is the following set in ordered pair a function? This would not be a function. And the reason is because we have two inputs, and we can't have two inputs. You can have two outputs, just not two inputs. Is the same thing. Just remember it needs to also pass the vertical line test. For number 22, that one has all different inputs, 1, 3, 2, and 5. This one actually is a function. And remember to check it, you could graph. Just remember a graph needs to be able to pass that vertical line test. So if you have something that looks like this on your graph, that is not a function. Okay? Let's go on and look at 23. Evaluate f of x is equal to 3x minus 5 when x is equal to negative 2. X is equal to negative 2. So I'm just going to rewrite this down below. You're basically plugging in negative 2 here. So 3 times negative 2 minus 5. That's going to be negative 6 minus 5, which is equal to negative 11. Okay. For number 24, for f of x, rewrite this since we're covered, equals 3x plus 2. what is the value of x when f of x is equal to 29? So that means we're plugging in 29 where that f of x goes. So we'll have 29 is equal to 3x plus 2. I'm going to subtract 2 from both sides, so I get 27 is equal to 3x. And then divide both sides by 3, x is equal to 9 for number 24. For 25, it says find the x and y intercepts for each equation. So essentially what we're doing here is we're just making y be 0 and x be 0. So the first thing I'm going to write is y being 0. So I'm going to say x minus 2 times 0 is equal to 8. So I'm basically just trying to get x all by itself. That means x minus 0 is equal to 8. So x is equal to 8. Okay. Then I can also find the y-intercept. So that means I would say 0 minus 2y is equal to 8. Which is just negative 2y equaling 8, and dividing both sides by negative 2, y is equal to negative 4. So you could say these two things, or you could say 8 comma 0 and 0 negative 4 as your answer as well. So any of those answers would work. I'm going to do the same thing up here. This says 4x plus 5y is equal to negative 20 for number 26. Again, I'm going to do x-intercept first, so 4x plus 5 times 0 equals 20, which is essentially 4x equals, negative 20. So that means x is equal to negative 5, or you can say negative 5 comma 0. And then the same thing for your y-intercept. 4 times 0 plus 5y equals negative 20. So that means 5y is equal to negative 20, or y is equal to negative 4, which would mean 0, negative 4. So again, any of these solutions would work. That's halfway done with our review, so I'm going to pause the video here, and you'll see a part 2 come out later, so you can check questions 27 through 52. Good luck on your exam!